everyone. Welcome to the M2L31 series Level 1 training course. Today we will introduce one of the peripherals inside the low power domain of the M2L31 series, the Low Power UART. What is the Low Power UART? The full name of Low Power UART is Low Power Universal Asynchronous Receiver and Transmitter, a low-power serial communication interface used to transmit data between devices. Low Power UART uses only two lines, transmitter, TX, and receiver, RX, to communicate between devices. Data is transmitted in bytes and does not require an additional clock line. Therefore, Low Power UART provides full duplex and asynchronous serial communication. In addition, Low Power UART supports a unique feature called Auto Operation Mode. With this mode, the M2L31 series can transmit and receive data within the low power domain without CPU involvement, achieving the most power-efficient and highly automated data handling mechanism. In the M2L31 series, the low power domain includes a dedicated peripheral called the Low Power UART. In the M2L31 series, what are the differences between the Low Power UART and the standard UART? Aside from having different clock sources, the main difference is that the Low Power UART only supports RS-485 and single-wire data formats, and the system provides only one Low Power UART module. When used together with the Auto Operation Mode, it enables data transmission or reception through the Low Power PDMA, even while the system is in Power Down mode. Next, we will introduce the main features of the Low Power UART. We will explore them from four key aspects: communication, data format and control, error detection, and low power application. First, let's talk about communication. The Low Power UART supports full duplex data transmission, and it can work in RS-485 mode or single wire mode. It also supports low power PDMA, which is very important when you want to reduce CPU activity and lower the system power consumption. Next, in terms of data format and control, the Low Power UART is very flexible. You can program the data length to 5, 6, 7, or 8 bits. You can choose the parity, even, odd, none, or a fixed parity. You can also set the stop bits to 1, 1.5, or 2 bits. It includes a programmable baud rate generator and 16-byte TX and RX FIFOs. In addition, it supports hardware auto flow control using the NCTS and NRTS pins. You can set the RX FIFO trigger level and use timeout detection, which is especially useful when receiving packets with variable lengths. It also has auto baud rate detection and compensation, making communication more convenient. For error detection, the Low Power UART provides several features that help increase the reliability of the transmitted data. And finally, in low power applications, the Low Power UART supports wake-up functions, and most importantly, it supports Auto Operation Mode. This allows the system to transmit or receive data without waking up the CPU, which is the key to achieving very low power consumption. Now let's take a quick look at the Low Power UART packet format. A packet starts with the start bit, which marks the beginning of the transmission and is always 1 bit wide. Next are the data bits, and this can be configured to 5, 6, 7, or 8 bits depending on your application. After that, we have the optional parity bit, which is used for simple error checking. You can set it to even, parity, odd parity, or disable it entirely. And finally, the packet ends with the stop bits, which indicate that the transmission is complete. You can choose 1, 1.5, or 2 stop bits. For the Low Power UART, the clock source can be selected from LXT, MIRC, or HIRC. One thing to keep in mind is that the Low Power UART clock frequency must not exceed 30 times the HCLK frequency. So when you're choosing the clock source and setting the system clock, make sure this ratio stays within the allowed range. Now let's take a look at the block diagram. As mentioned earlier, the Low Power UART includes several key components. It supports a programmable baud rate generator, which is driven by the Low Power UART CLK source. It includes hardware autoflow control, implemented through the Low Power UART NCTS and Low Power UART NRTS signals. It provides a 16-byte receive FIFO and a 16-byte transmit FIFO. And finally, it supports 10 different interrupt events for flexible control and monitoring. The Low Power UART supports 10 different interrupt events. This table highlights some of the most important ones, along with the related registers and their trigger conditions. 1. Transmitter empty. This interrupt is triggered when the Low Power UART finishes sending a transmission packet. 2. Wake up. Used to wake up the MCU from low power modes. 3. Buffer error. Triggered when either the receive FIFO or transmit FIFO overflows. 4. Transmit holding register empty. This occurs when the transmit FIFO becomes empty. 5. Receive data. Available, triggered when the number of bytes in the receive FIFO reaches the programmed threshold, which can be set to 1, 4, 8, or 14 bytes. 6. RX. Timeout. This happens when data stays in the receive FIFO longer than the configured timeout period. Finally, let's talk about how the auto operation mode works when transmitting data. The goal of the Low Power UART is to allow data transmission or reception without waking up the CPU, even while the system is in power down mode. The Low Power UART can be triggered by several different sources, such as low power TMR, TTMR, or WKIOA0, to start sending data automatically. When a transmission begins, the Low Power UART will automatically enable its clock and then issue a request to the Low Power PDMA to move the data. The key point is that after the Low Power PDMA finishes the transfer, the Low Power UART will automatically turn off its clock, achieving true low power operation. Now let's talk about how the auto operation mode works when receiving data. When the baud rate is 115,200, the Low Power UART will automatically turn on its clock as soon as it detects incoming data. If a receive timeout event occurs, it will wake up the system. After this event, the clock will be automatically turned off again. One important thing to note: if your application needs to receive data continuously at 115,200 baud, you have to set CKAWOEN to 1. This keeps the Low Power UART clock running so it can properly receive all incoming UART signals. That concludes our training session on the Low Power UART. We also have a video showing example programs using the Low Power UART, so feel free to check the video list for reference. Thank you for watching, and if you'd like to learn more, please don't hesitate to contact us.